What's up, Codervite? Welcome back to another data structures and algorithms video. I'm Elizabeth, and this week we are going to do another two-pointers problem. This is going to be similar to last week's problem, but we're going to raise the stakes a little bit, make it slightly harder, kind of expound upon it. Expound upon it is definitely wrong, whatever. So yeah, let's get into this week's problem. Okay, so first let's do a little bit of a recap on what the two-pointers pattern is. So two pointers. In many problems involving arrays or linked lists where you're looking for a set of elements that fulfill certain constraints, we can apply this two pointers pattern to avoid looping over that array multiple times. Because we use two pointers, we are able to process two elements per loop instead of just one. So this helps us drastically improve all of our, time complexity in terms of looking for two elements in an array rather than just one element. So some common patterns in the two-pointer approach are two pointers, each starting from the beginning and the end of the array, and then kind of converging towards the middle, depending on the problem. It depends what they're asking, but like for why you would move one pointer versus another as they converge towards the middle. But basically, yeah, starting from either end until they both meet in the middle, or one pointer moving at a slow pace and one pointer moving at a faster pace, let's say twice this speed. So this is going to be another problem where we are applying that first approach, where we're using two pointers and they're each going towards the middle until they converge. So what's this week's problem? Given an array of unsorted numbers, find all unique triplets in it that add up to 0. So this is kind of a more difficult problem than last week's problem because we're not just looking for pairs. We're looking for, triplets. So not two elements, but three elements. And they have to add up to 0. So let's look at an example. Here's an array with, you can see they are unsorted, right? All of the numbers are not in order here. And the triplets that add up to 0 are as follows. So we have -3, 1, and 2 make 0, -2, 0, and 2 make 0, etc. So these are all the possible unique triplets in this unsorted array that add up to 0. So what's our approach here? If we are doing a two-pointer approach, this is the two-pointer pattern, how are we going to find that third triplet here? How can we kind of modify the pattern that we've learned to solve this problem? So I think this is a really cool problem. When I kind of like understood the solution, I was like, huh, that's pretty genius. So essentially the approach using the two-pointer approach for this problem is as follows. So here's our array, same array as from the previous slide. And our first thing that we have to do is we have to sort it because we're going to use those two pointers, and then to determine which one to move, it's going to have to be, is our sum less than or greater than our target sum, right? That's going to determine, do we move the left pointer or the right pointer? And in order to do that, we need the numbers to be in sorted order. So the first thing we do is sort the array. Okay, magic. The second thing we do is we loop over the array. And what do we do as we're looping over this array? So what we do is, as we're looping over the array, you can imagine I here is our, index for where we are in the loop in the array. And what we do is we take the negative of the array at I as the target sum. And you'll see why in a second, why we're taking the negative. So let's just add some more, useful imagery here. So for our first number, we have -3. So our target sum is now going to be the negative of -3, which is +3, right? So our target sum is +3. Now, what do we do now? So now we have our target sum is 3. We're looking for the other two elements in this array that, when added together, equal this target sum, which is 3. And why is that? Because we're looking for triplets that add up to 0. So if one of our numbers is -3, we need two other numbers that combined will equal +3, and that will bring us to 0. So this is like a really cool, it's actually not much harder than the problem we did last week if you know this trick. But it's kind of a way to use the two-pointer approach that we did last week and just modify it slightly to fit this specific problem. So let's watch that in action. So we have our target sum is equal to 3, and now we are going to initialize our two pointers, right? Now we're going to look for the pair of the integers that add to the target sum using the two pointers as we did in the previous video. So this is going to be exactly the same as last week. So here we have our two pointers. We have one at the beginning and one at the end. And now we are going to add them together and see, do they equal 3? Are they less than 3? Are they greater than 3? Etc. So 2 and -2 added together equals 0, which is not what we're looking for, right? We need the whole triplet to equal 0. So if it's 0 and we're looking for 3, that means we need a bigger number, right? We need more bigger numbers as a pair to add to equal our target sum. So that means we're going to move our left arrow up so we can have a bigger number. Okay, so 2 and -1. Okay, we're getting closer. That equals to 1, but it's still not what we're looking for. 2 and 0, also closer, but not what we're looking for. And finally, we get to 2 and 1. And so now we have our triplet, right? We have 2, 1, and -3 as a triplet equals 0. 2 and 1 as a pair equals our target sum, which we have said is now 3. So that's kind of how this works. Let's walk through just one more. So iterate, we found a triplet. So now we have our target sum. This is -2, so our target sum is going to be +2. And then we do the same thing, right? We initialize those two pointers. 2 and -1 equals 1. That's too small, so we're going to have to move our left pointer up. And 2 and 0 does equal 2. So we found another triplet. So our next triplet is going to be -2, 0, and 2. And that's kind of essentially it. You just walk through each element and then look ahead, right? We don't have to look behind because we've already taken care of those elements. But we try and find the pair of elements that equals wherever we're at in our iteration, the negative of that, which will ultimately mean that all three together equals 0. So let's code this out. Okay, so I'm in my Visual Studio Code editor as per usual, and I just have a blank file here. So let's fill in some of these test cases to get us started and define some functions. Okay, so let's say, I don't know, let's call our function maybe like triplets to 0. That works. And we're just going to get an array, right? Okay, so there's our function. And then down here, I am going to just define some test cases. So here we have triplets to 0, and I am going to paste in some of the stuff from these slides. So here is exactly the same array that was in the slides. And so what we're expecting to get here will look something like this. And then let's do one other. So let's say console.log triplets to 0. And this is going to be just another array of numbers. And then for this one, I think what we want, we're expecting our triplets to be, will be something like this. So we have -5, 2, and 3 makes 0, and -2, -1, and 3 also makes 0. Okay, so here are our test cases. We've got that covered. And here's our function triplets to 0. So let's start this off. So what did we say in our algorithm? The first thing we want to do is we want to sort the array. Otherwise, we can't use our two-pointer approach that we've learned. We wouldn't know it wouldn't matter which pointer we moved if we don't know what's coming next. So the first thing we want to do is we want to sort that array. So we can just do r.sort. And then that takes a little function here. So A and B will refer to the two elements that it's looking at to sort. And we just want to return, we don't have to do a return for a one-line arrow function. So we want to return, what is it? I think A minus B. And that will just sort it in order. And this is something that you should all know. If you don't know, go look at the MDN page for array.sort. But that's kind of like how a very quick, easy way that you can sort any array of integers in JavaScript. And the other thing to note here is this actually is modifying the array we're not creating a new array of sorted numbers. So again, things to know depending on the problem, but that's important. So now our array is sorted. So the first thing we want to do is we want to loop over the array just with a regular for loop, right? And we want to basically have this like concept of a target sum that's not 0, a new target sum, which is whatever is that element that we're looking at, it's negative. So first, let's also define maybe like our triplets, because we know we're going to want to return an array of triplets here. Let's do that really quick. Okay, so now we have kind of our scaffolding here. So let's do a nice little for loop. So let I equal 0, I is less than the array dot length, I plus plus, nope, plus plus. Okay, so now what are we doing, right? We want to, our target sum, right? So this is going to be our let target sum is going to be the negative of the array at I, right? So that's what we're going to be using as our target sum as we use that two-pointer approach for the rest of the elements in this array. And now I think what I want to do is I actually want to make a different function that we're now going to call from within this triplets to 0 function, which is actually going to look very similar to last week's problem. And it's going to do the two-pointer thing where we pass it an array and a target sum, and then it just does the 2 pointers and then, does the thing, right? So let's do that. We can do that down here. So this is going to be search pair, right? Where we're looking for the pair of numbers that equal to the target sum. And so this is going to take, again, similar to last week's problem, this is going to take an array, a target sum, and then it's also going to take the left pointer because we want to know where is that left pointer starting out at, because we're not going to be just starting it out at the beginning of the array like last week's problem, because we are only looking ahead, right? We're looking past whatever we're at in this iteration. So we get a reference to where are we starting our left pointer at. And then I think the other thing we want to do is we want our triplets, right? Because we're gonna get a pair here and we want to add it to the triplets. So let's pass in the triplets array. Okay, so here's our search pair, and this is going to be very similar to last week's problem. Now, before we write that, I think I want to just I want to do something here that is different than what we've done so far. And that is because this problem is asking for unique triplets. What does that mean? So if there are 2 of the same number in the array, that means that the triplet will be the same for both of those numbers because it's the same number, right? So let's say we have an array, we can just have an array of length 3, and that equals to 0. So let me think of an example here. So let's say we have 2, 2, and -4. So the triplet would be 2, 2, and -4. That would equal 0. So if our target sum starts out at 2, and the pair that we're looking for is 2 and 4, we'll find it with the first iteration. If we move on, and the next number we're looking for is also 2, we're also going to find 2 and 4, even though it's a different 2 that time. And the triplet will be the same, even though it is finding actually different elements, if that makes sense. So because the array is sorted, and all of the numbers that are the same will be next to each other in the array, to avoid having those duplicate triplets, we can just check, is the number that we're looking at this point the same as the number that we just looked at? And if it is, we can skip it. We don't have to do anything because we've already found the triplet that matches that target sum, if that makes sense. So to do that, I think we just want to do something like if, so basically the array at I, which is what we're looking at, is equal to the array at I minus 1, so it equals to the one we just looked at, right? We can just continue. We don't have to do anything because we've already found a triplet if it exists, and it's in our triplets array. So we don't have to worry about that. And then the only other thing I would add here is we want to make sure that I is not equal to 0, because then there is nothing at -1, and that won't work. So let's say if I is greater than 0, and so I just want to just make a comment so it's clear here, and also get rid of that. I don't want that. That we want to avoid duplicate triplets. If the element we're looking at is the same as the element we just looked at, its triplet will be identical. Skip it. Okay, so hopefully that's clear, and we'll walk through this, but that's kind of like a gotcha here, because they ask for unique triplets, and we don't want to just have the same triplet more than one time, even if it's like it's two different of the same integer in the array, because there are doubles of that integer. Okay, so that takes care of that. So what's the rest of this? So then if we don't have a duplicate, we can just do what we wanted to do, right? And we just want to search pair, right? That's going to be our function that we're about to fill in, which is going to do the, classic 2 pointers pattern here. And we want to pass it the array, the target sum. The left pointer is going to be wherever we're at in this iteration +1. It starts after this iteration. So that's going to be I +1. And then we'll pass it the triplets. And we're going to just modify this triplets array. So we're not even going to return it. We're just going to pass it around, and it's going to be a reference. And we're just going to modify that, down here in this function. And that's it for this function. So if we write this well, this one will just work. So let's move down to this one and see what we have. Okay, so we have our array, we have our target sum, which is the negative of the, the spot that we were iterating, in the outer function. We have our left pointer. What do we not have? We don't have our right pointer, right? So let's start that. Let's say let the right pointer equal the array length -1. So that will start the right pointer all the way at the end, and the left pointer will be 1 after whatever the iteration was in the the outer function over here. And then we basically, again, this is going to look very similar to what we did last week. We're going to just do a while loop while that left pointer is less than the right pointer, so they have not converged yet. And then what we basically want to do is we have a few different things, right? So the easy case will be if first we need a current sum, right? So let's say const current sum is equal to the array at the left pointer plus the array at the right pointer. Okay, so now we have a sum that we're dealing with. And if that current sum is equal to the target sum, we've found a triplet, right? So we found a triplet. Yay. Okay, so what do we want to do here? We want to triplets.push, and we want to push into that array. We want to push the I guess we could just use that target sum, right? Because the target sum is just the negative of whatever was there. So we can just push the negative of the target sum, which will be the original, the original number that we were looking at. So that is the negative target sum, and then we want the array at the left pointer, and then we want the array at the right pointer. Okay, so that's great. Now, unlike the other function that we did last week, we don't want to exit here because we found something. We actually want to continue, because if there are other triplets that equal this target sum, we also want to capture those. So instead of just, returning here, right? I think in last week's video, we put a break keyword in here. We actually just want to continue to iterate, right? So we want to both push the left pointer up and also bring the right pointer down. And that will, right, so we're going to continue to look for other triplets that aren't what was at the left pointer and the right pointer. So we're just going to kind of converge towards the middle and continue until they actually converge. Okay, so we found a triplet. That's, one case, right? So let's see what happens, our other cases here. So here we have an else if, and now we want to, make some logic for what if the current sum is not equal to the target sum. So in this case, we want to, right? So if the target sum is greater than the current sum, we need a bigger number, right? So we need to move that left pointer up. And then what's our other case, right? Else if our target sum is less than the current sum, we want to move the right pointer down because we've overshot, right? And we need to have smaller numbers. So that will be our right pointer minus minus. Okay, so those are all of our cases. There is, a few different things here that we didn't deal with yet though, because here we have we're moving our left pointer and we're moving our right pointer. And we essentially want to continue to move the left pointer and the right pointer up or down until we get to numbers we haven't seen yet. It's the same problem that we kind of came up against up here, where we don't want to have duplicate triplets. So we can't just look at the next one, because if the next one is the same number, even though it's a different element in the array, we still want to avoid that. So how can we do that? So we can just add in another while loop here, right? So this is going to be another while loop, which is basically going to say, right, like move the left pointer up until we get an integer that is different than the one we're looking at. So that's kind of the goal of this little sub while loop here, because we can't just, assume that we can move the pointers and then we have new triplets or new pairs in this case. So here we would say that we still want to check, right, while the left pointer is less than the right pointer, right? Because if they converge, we can just stop. And the array at the left pointer is equal to the array at the left pointer minus 1. So again, we are moving the left pointer up while this is the case. So we want to move it up until it's not the case, right? So this signifies that it's the same element again. And while that's true, we want to left pointer plus plus. So continue to move that left pointer up while the left pointer is less than the right pointer, and they are the same, the element before it and the element we're looking at currently. So again, this is to avoid getting those duplicate, having those duplicate triplets sneak in at any point. So that's, it's a little confusing, but if you think about it and you also draw it out, I think it will help sort of visualize what's actually happening here. And of course, we have to do the same for the right pointer, right? So here we can just do while the same thing, while the left pointer is less than the right pointer, and the array at the right pointer is equal to the array at the right pointer. Now this is going to be plus 1 because the last right pointer element we looked at will be after it in the array, not before, because we're converging towards the middle. So that will be right pointer plus 1. And then here we just want to, keep moving that right pointer down until that's not true. So again, this is all to avoid duplicate triplets. And I strongly suggest that you kind of remove these lines, see what happens, and then add them back in and kind of walk through why we need these to avoid those duplicates. But I think that's it. I think that's everything we have to do here. We're pushing our triplets. This is passed by reference. So this is just a reference to, the triplets that's here. So when we return the triplets, it will hopefully have all of the triplets that are meant to be in this array. All right, so let's run this and see what we get here. Cool. Where is that? 39. So I think we are missing a, yeah. Okay, so then, wait a minute. Okay, so that's an if, and it's closed. That's closed. That's closed. That's closed. That's closed. The next thing we need, we still have a big while loop that we have to close. So I think that needs to go here. All right, try one more time. Okay, so let's see what we got. So we got -3, 1, and 2, -2, 0, and 2, -2, 1, and 1, -1, 0, and 1. And then we have -5, 2, and 3, and -2, -1, and 3. All right, so we got what we set out for. And again, I think the gotchas here are, all of those, avoiding the duplicate triplet pieces of this. Those are like oh, what is that? And why is that happening? So I think the best way to kind of figure that out is to remove those lines, see what you get, obviously use an array with duplicates, and then put them back in and kind of walk through maybe with a pen and paper or a debugger to see how you are actually avoiding those duplicates in both of the finding the pairs and also in the outer function when you're actually just looking for the target sum and then calling the search pair function. But otherwise, yeah, that's it. I hope you guys enjoyed this. Okay, and that's all I got for you today, folks. I would say this is more of a, medium hard problem. I think we'll do one or two other two-pointer problems, and we will definitely be doing a problem where instead of the two pointers converging towards the middle, we'll do the two pointers with different speeds kind of problem. So you have all of that to look forward to. I hope you all are having a great 2022 so far. I know I am. And yeah, have a great week, everybody. See you next time.